Hello everyone, welcome back to the Matho332 channel with Mr. Lee. I'm Mr. Lee, and so we're starting the Unit 4 notes now, starting with proportions. So when two things are fractional in relationship or have ratios or involve division are equal to each other, you end up with a proportion. It will look something like A over B equals C over D, where either probably three of your numbers are going to be known or described in some way, and you're trying to solve for the other one. The beautiful thing about proportions that are set up like this, where everything is in a fraction, is you have something called cross multiplication. So normally when you have fractions, you try to clear the denominators. That would involve multiplying by B and D, but in short term, by doing that, the D ends up multiplied on the other side, and the B ends up on the other side also, and you end up with this equation, A times D equals B times D, where one numerator and the opposite denominator are multiplied equal to the opposite pairing. Some people have kind of referred to this before as a butterfly effect because of how this works. So if you know the butterfly method or something, you've heard it before in the past, this is what they're talking about. So let's look at some equations where this would be helpful. So 5a plus 10 over 15 equals 3a minus 18 over 3. Again, my suggestion is to use this cross-multiplying technique. Those two will end up on one side, so we'll have 5a plus 10 times 3 is equal to the opposite set. And order here does not matter. You can put them in either order. Generally, I would like to put the constant first, but I'm really just trying to follow this ordering here. This equals to 15 times 3a minus 18. So that would be, what, 15a plus 30 when you distribute is equal to, it's like 45a. 15 times negative 18 is what, negative 270? Because once you do this, and once you multiply things out, you'll notice that these equations start to look like some of your linears you've dealt with in the past. So you move all of your a's to one side and all of your numbers to the other side. I'm going to add the 270 and subtract the 15a so that things are positive to get 300 equals 30a. And then once you're there, you can divide by 30 to get that a equals 10. One thing you can always do with these is you can plug them back in and see. If you plug in 10 here, 5 times 10 is 50, plus 10 is 60. 60 divided by 15 is 4. 3 times 10 is 30, minus 18 is 12. 12 divided by 3 is also 4. So this can be really helpful as a technique, as plugging back in if you don't trust yourself necessarily with the fractions. Let's move on number 2. Same strategy. So it'll be 11 times c equals 4 times 3c. So you get 11c equals 12c. And you'll notice that means when you subtract 11c to the other side, there's nothing left on this side, so you get 0 equals c. So what this is telling you is that if you plug in 0, that these things should be true. Now one thing to note, if you get 11 equals 12, this means no solution. It's impossible. But 11c equals 12c, as you just can see, is possible. It means c is 0. Similarly, if you look at these fractions, 0 divided by 4, 3 times 0 is 0, 0 divided by 11, they're the same because 0 divided by anything is always going to be 0, regardless of what you're dividing it by, as long as it's a number and not 0 itself. We're going to leave 3 for you to practice yourself. So now let's look at number 4. It works the same even with algebra. So it's 3 times x plus 1 equals 4 times 2x minus 3. So 3x plus 3 equals 8x minus 12. And from here you'll solve. I'm going to get all my x's to the left just to see what that would look like. Subtract 8x. So if my x's are going left, my constants are going right. So this will be negative 5x equals negative 12 minus 3 is negative 15. And when you divide by negative 5, you get that x equals 3. And you could plug this in or not as you see fit. The point is that it does work. Now, proportions also come in word problem form, so I want to look at a few of them on the next page as well. So set up the proportion and solve. The weight of a person and the amount of blood they have is proportional. Suppose a 170-pound person has 5 quarts of blood. Find out how many quarts of blood a 70-pound child would have. Okay, so we're looking for a ratio that will look something over something equals something over something else. I personally always like to put my unknown in a numerator when given the choice. So find out how many quarts of blood a 70-pound child would have. I'm going to call that ratio of blood to weight like this. X over 70 is my ratio of the unknown number of quarts of blood that a 70-pound child would have. When I know that 5 quarts of blood pairs with an 170-pound person, and these should be equal because it says they're proportional. So again, same strategy. If we cross multiply, you set it up, and once you set it up, it's exactly like the last page. 5 times 70 equals 170 times x. So this is 350 equals 170x. And those are both multiples of 10 for sure. So we can divide by 10 on both sides. So 35 equals 17x. Either way, when you divide by 17, you get that x is 35 over 17 as a fraction. If you need a mixed number, you like how many times does 17 go into 35? Should go twice, minus 34, the remainder of 1. So that would be 2 and 1/17 quarts of blood. So the setup is really the main deciding factor here based on what is unknown. Like I said, I always like putting it in the numerator when given the choice, but it doesn't really change because if it's in the denominator, if this had been flipped, this would also have been flipped and you would have gotten the exact same equation. Notice here, if we look at this, 170 over 5 equals 70 over x. You get the same cross multiplication. This one's now on the right, and 5 times 70 is on the left. So it really just changes the order, but we know from an equation, it doesn't matter if left equals right or right equals left, they are the same. So an alligator's tail length is proportional to the length of its body. An alligator with a 7.9 foot body length has a tail measuring 8.9 feet. What is the tail length of a baby alligator who has a body of 4.8 feet? So here, they want to know the tail length, so my unknown is tail length for the baby. So I'm going to put that in the numerator. So we have tail to body is our ratio. That's proportional. So for the baby, I know unknown tailed length with 4.8 feet of body length. But for the adult, again, I want tail first in the numerator, body second. So that means 8.9 feet for the length of the tail first over 7.9 second. One thing that's annoying with decimals is the arithmetic involved, but here's what we will do. We will still pair them. 8.9 times 4.8 equals 7.9x. One thing you could do is increase the ratios a little bit. Let's just multiply. If you can do old school multiplication to the side. 72, carry the 7, 8 times 8 is 64, plus 7, 71. Add a 0, 4 times 9 is 36, so you 6, carry the 3, 4 times 8 is 32, plus 3 is 35. You get 2, 7, 2, carry the 1, 4. There's 2 numbers behind the decimal, so you get 42.72. And from here, all you would do is divide by the 7.9. Now, if you have a decimal like this, and you want to clear the decimals, if I move the decimal place twice in the numerator to get me 42.72, I also have to move it twice in the denominator, which means adding a 0. So 42.72 over 790, and then you could reduce from there to get the actual answer and potentially make it a mixed number. And that's really all there are for proportion equations.